All right, so in this section, we're looking at different types of ways to look at data, and one of them is called a stem plot. Now, you learned about stem plots. You call them stem and leaf plots, right, in 8th grade or something, maybe. But a stem plot is just a way that we organize data. Now, what we do, so imagine this is a set of data that represents some test score in a statistics class, okay? And you can pick out which one you want or which one you probably think you got. But the way we set this up is the tens place will represent the stem of the data, and then the ones place will represent the leaves of the stem and leaf plot. Okay, and so what I do is I go like this. I go 3, 4, 5, 6, 7, 8, 9, and 10. And then I draw my line here, right? And so this would represent 30, 40, 50, 60, 70, 80, 90, and 100. Okay, so some people scored in the 30s, some in the 40s, some in the 50s, and that's where their numbers would represent. And so you can see that the first test score that I got was a 33, and so I'm going to put a 3 there. So that number represents 33%. Okay, and that's the only person that scored in the 30s. Then I have 42, 49, and 49, and I do put duplicates. Okay, then 53. And I'm trying to line up my numbers as I go down, and that way, and I'll show you why in a minute. 53 and then 55. And we have 61, 63, 67, 68, 68, 69, 69. Okay, so there are a lot of people that scored in the 60s. Okay, you can already see the usefulness of a graph in statistics. We start to understand what the scores, the general population scores were, and we can answer questions based on that. Then I have 70s, starting with 72, 73, 74, and 78. And we have 80, 83, 88, 88, and 88. Okay. Then we have 90, 92, 94, 94, 94, 94, 96. I'm sorry. And then 100. I'm sorry? You think they might have cheated? That might be a statistical question, a hypothesis that we're going to formulate. Now, I want to go back, and I know that there were 30 people in this class, and so I'm going to make sure that I recorded all of them. I'm going to quickly count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. So I've got all my data points. I want to make sure I put down here a legend. If I know how to spell it. The legend is Mr. Heb. Oh, no, I'm just kidding. So I'd put a 5 and a 3, and that represents a 53% on the test. Okay, just so, right? So the 5 and the 3 here represents that score was a 53% on the test. That's how I read that key. Okay. Now, why is this a good graph? It gives us a good representation. We can see where people scored the most, right? But here's the magic of a stem and leaf plot that we often don't think about. If I turn this sideways, then I can look at the data and what it truly looks like, right? And I can see that more people scored, right, in the lower, not more people, but it was more skewed to the left, right? Remember that word skewed? Okay, and then I have a bunch over here, right? And so that gives me the ability to look at that data in a different way. It also protects my data in that I have every data point in here. Now, I wouldn't want to use a stem and leaf plot if I have 1,000 data points. Right? Ain't nobody got time for all that. Okay? But when I have 30, it's pretty simple to do that. Okay? Questions on that? Now, what we can also do, and it's something that's important in statistics, is being able to compare data. And so what we could do is down here I've got another set of data, and let's say that I decided that I didn't like the scores of that test, and so I decided to let the class have a retest. Right? Maybe, you know, the parents down here of the students down here complained a lot, and so I said, all right, fine. I'll let them study and we'll do a retest. And we'll compare the data. Right? And so what I can do is a side-by-side stem plot. And what that looks like is I draw another bar over here, and I have leaves that go on the other side. Okay? And so when I go down here, and I'm not going to be able to complete it because I wasn't smart enough and left myself enough room, but I can put a 57 here. Oh, you can't see it. Right? 57 there, and then a 59. Right? And then a 60, and a 60, and a 62, 68, and what are we finding? Overall, people did a little bit better, didn't they? And so I'm able to compare the data sets based on using a side-by-side stem plot. Okay, I'm able to compare them, and when I compare data sets, I'm using those ER words: bigger, right? Larger, more spread outer, right? Mr. Heber, that's an ER word. All right, and I can continue with the side-by-side stem plot. Everybody got that? Do I need to continue that? Everybody understand what a side-by-side stem plot looks like? You'd have, now, what the danger is also, remember when I said when I'm looking at this side over here, I can just turn it over this way? And my lower values are on the left, my bigger values are on the right, which is what makes sense to us. But if I do a side-by-side and I try to turn it this way, oh man, what happens? My lower data values are on the right instead of the left. And so I have to make sure I invert that in my mind, right? I know that the lower data usually goes on the left. Okay? Cool? Yeah. All right. Now, the only other thing that's in this section that I wanted to go through is what we call bar graphs. Okay, again, this whole unit is talking about ways that we look at data, right? So, so far this semester we have learned how to collect data, right? How to do it randomly, or do an experiment or a simulation or sampling methods, and do it in a way that is will give us good, accurate data. But then what do we do with it? Well, the first thing we have to do is we have to look at the data. We have to graph it. Okay, so a bar graph is yet another way that we can graph data. And usually, well, not usually, when we use a bar graph, it's going to be categorical data. It's counts. Okay, so I have this random data up here of age groups and Facebook users, the number of Facebook users. And what I want to do is I want to do a bar graph based on the proportions of people who use Facebook. Now, what you'll notice on here is that these will represent my bars, and so down here I will have one bar that will be from 13 to 20, right? And so that bar has a 31%, and so maybe I go 10, 20, 30, and so 31 would be up here, and so I draw my simple bar, right? And that represents 31% of Facebook users are between the ages of 13 and 20. Okay. Then down here, I would do another bar, and this would be from 21 to 42. Now, this, what's the difference between 13 and 20? 7 years, right? This is a little bit more, isn't it? 21 years. Okay? So, in a bar graph, it doesn't matter. I set my own bars. Okay? When we talk about a histogram on Wednesday, histograms are different. The width of the bar has to be the same. Okay? But here it doesn't matter in a bar graph. All right, so 24% for between, so I'll go right around there. And then between 43 and 55, be 19%. You know how accurate this data is?
200.
I just made it up, yeah. And then 56 and up is going to be 26%. Okay, now what's good about a bar graph? Well, it gives me an idea of who is using Facebook more often, right? And you know, Facebook is one of the biggest data collection agencies out there, right? They collect data all the time. You simply talk about something and it shows up on your Facebook page, right? But one of the questions I might ask would be why this category is almost as high as the younger people, younger generation. And so I might want to do a study of why that might be the case. And I made up this data, but I can imagine that maybe it's because grandkids, right? And so if I'm separated, I don't have any grandkids, but if I'm separated from my grandchildren, then I would want to look on Facebook to see pictures of them and see what they're up to. And so that's maybe why that category is a little higher, right? And I would bet if in real life, this might even be lower because people are using other social media because the old people are using the Facebook, right? And we don't use the Insta faces and what's the other one? The Twitter and Snapface and all those things, right? Cool. Any questions on bar graphs? Yeah, they are. Yeah, and bar graphs always will have a gap between the bars. Histograms never have gaps, unless there's missing data. Okay, bar graphs always will have a gap between the bars. Histograms will only have a gap if there's missing data, if there's a zero value between, and I'll show you that on Wednesday. Cool? Beans. All right, that's it for the notes.